Alright, so functions today, guys. Today we're talking about functions, and, well, we've been going at it for quite some time with this series, this Python series, specifically a Python series for AI. We're just learning the Python that is necessary for artificial intelligence. Now, artificial intelligence is very broad. It's, you got computer vision, you got natural language processing, which is probably the most popular one because that's when we talk about transformers, that's when we talk about GPTs, that's when we talk about, large language models. It's pretty trendy stuff, right? AI agents. NLP is definitely the most unsupervised learning one at the moment. Specifically business machine. But there's also computer vision. There's also time series analysis that's used in finance for predicting, for logistic regression, in order to make a classification or to predict if a specific customer is going to churn or something like that. There's many applications in AI, in machine learning specifically. And yes, there's a difference between machine learning and AI. But we are slowly building ourselves towards understanding all of these topics. And we're starting from ground zero, and this is why we're doing this Python series. Last time we already talked about lists and dictionaries, how lists and dictionaries are like data structures are extremely important for storing and manipulating data in memory. Now, this is going to be extremely important, especially once we get to chatbots or actually creating legit chatbots and not like the demo programmatic exercise chatbots that we created in previous videos. They were just exercises, really, just to get your coding skills a bit more up to speed. But real chatbots are a bit have more sophisticated code, and we really need to start mastering the manipulation of these data structures if we really want to become good at this. But today we also have to talk about something else called functions. Functions, if lists and dictionaries are a very essential way for AIs or chatbots specifically to memorize, or to have memory, quote unquote memory, right? Then functions are a really good way for storing an AI's thoughts or actions or intentions. Functions give tools to an AI. They provide tools to an AI. Especially when you're talking about AI agents and stuff, like when you have your large language model that is really just a machine. It's really, if you think about it, a large language model is just a really complicated function. You input something in and then you get something back out. It's a very complicated statistical function, a large language model. So if you go on the early days in ChatGPT, it was just that, a very large statistical function. Now AI agents changed the game because AI agents, now you can attach tools to these large language models. So these tools are actually just functions. They're specific functions that either call a specific API, an API is just a way for you to contact another application, or they can also contact a specific database, whether that's a tabular database or a vector database. That's in order for you to provide more context to your LLM, right? So this is how AI agents tend to work, really. Or just connect, or functions are also a good way to connect the output of another large language model to another large language model if you're going to be creating workflow patterns, right? With that being said, let's talk about functions. We already talked about the importance of functions. Now let's actually talk what functions actually are. Now if you're watching this, you're probably already familiar a little bit about functions. If not, that's okay. If you've been watching this series and making notes and everything, you would probably remember that in the very first episode, Start Coding in Python in 15 minutes, I mentioned functions. I believe I created a little animation or a little visual of what a function is, but either way, if you don't remember, that's okay. I'm going to recap it today. So here, imagine you have a bunch of ingredients for a cake. Now, I'm not really much of a cook, to be honest. I'm just a nerd who cannot cook, but I need to learn to cook because there are nerds out there who can cook, and that's awesome. I admire those nerds. I want to become one of you guys who can cook. With that being said, imagine you have sugar, milk, flour, and eggs. So you take the sugar, milk, flour, and eggs, and you input it into a machine. This machine is what we human beings called an oven, right? We take the ingredients, we mix it, and we put it in the oven. And then what happens? Well, stuff happens. It heats up. The oven heats up, it does a bunch of stuff, does a bunch of physics, chemistry, whatever, and then you get back out something. You get a cake. This is a very good picture of what a function actually is. A function is really just a machine. That's all it is. Long story short, it's just a machine. You put something into the machine, you get something out. Now, this is not the end, like the end all be all for functions. Functions can really be rigorously like defined. Some of you are probably watching this because you want the rigor. You want the actual definitions. You don't conform to just silly analogies, right? You actually want the rigor. And I promise we'll get to that. But this series is also for everyone, and I need to pack this series up so that everyone can understand it. Right now, this analogy is a good analogy. Like you put ingredients into the machine and then you get back something out. But it's not an analogy that I want you to get married to. I don't want you to get married to this analogy. I don't want you to just focus on this analogy. But this is an analogy that can at least get you started with something. And that's what we want to do. We want to get started so that we can just like get to work and just like get our hands dirty. But this is not the analogy that I want you guys to like get married to, because there are ways to define functions that are a lot more formal. In mathematics, you use set theory and the concept of relations to really formalize the idea of a function. But we're not going to get into that today. Later down the line, we'll probably get into that. Either way, it's probably not that important for machine learning, but here at Allmind, we don't want to be mediocre AI engineers. We actually want to know how this stuff works, and we don't just want to like apply it. Like we also want to apply it and understand it so that we can be up to date. This is also for me, really. This is just me documenting my journey and how I'm learning everything, right? Because I don't know everything. I wish I knew everything, but I don't. I'm not going to pretend that I know everything. This is just me documenting my journey on what I already know and what I'm constantly learning. That being said, this is a good picture of a function. How do you define a function in Python, though? Well, if a function is just a machine that like where stuff is just happening, then in Python, you would call your machine, or you would let Python know that, hey, Python, I'm going to make a function here. How do you do that? Well, you type in def. Def is how you tell Python that, hey, I'm going to build a function right now. And then you can name it whatever you want. So let's just call it our function whatever. Not feeling very creative today, but that's how I'm going to name my function. So whatever, and then you actually define it with parentheses. Let's just erase all of this. That's how you define your function. Now, in these parentheses, remember what I said earlier? So, imagine these parentheses is like you putting something inside the function. Imagine these parentheses are like the gateway to the function, to the machine. You know how you open up your oven and you put something inside the oven? Well, imagine like these are the boundaries where you're putting something inside here. You're putting all your ingredients inside here. That's a good way to visualize it. Here, I'm going to be putting in my ingredients, or in Python, you would call it my parameters. So your parameters, this is what you would input into your function. You can put anything you want into your function. You can put an integer into your function. You can put a string into your function. You can put a float into your function, or a boolean into your function. You can put any data type into your function and get any data type out. It's up to you. Now, let's call our parameters or our ingredients x and y. Let's suppose I just want to put two stuff into my function. Only two kinds of stuff into my function. Well, I can do whatever I want with those two ingredients. Remember how we said stuff is happening inside the machine? Well, how do we actually, what is the mechanism, what is the procedure that is going to be happening inside this machine? Well, in order to define that, you would have to define that 1, 2, 3, 4 indentations to the right. So whatever you write here, right, 4 indentations to the right, that is going to be the scope of the inside of the function, if that makes sense. Anything that is outside of the scope, like here, for example, is not going to be part of the function, basically. It's not going to be part of the function. Here it's going to be part of the function. Here it's not going to be part of the function, if that makes sense. What am I going to be doing with x and y? Well, let's just say that I'm going to add x and I'm going to add y. So I'm going to add those two, and then I'm just going to add 7, whatever. Then what we want is, once our machine takes x and takes y, adds it together, and then adds it with 7, it's not going to keep that value inside. I need it to return that value to me. right? We want our oven to be able to return the cake. It wouldn't make any sense for me to put sugar, milk, flour, and eggs, and then yay, the cake is baked, but I'm not able to open up the oven. Now my cake is stuck inside the machine, right? That makes no sense. I need the machine to return back to me the value so that I can use that value for whatever reason I need it to. In order to do that, I would need to use the return statement. That's the return statement. How is it going to return whatever it calculated here? Well, that's what variables are for. I can call my variable anything I want. I could call it result if I want. And we already talked about variables. You should already by now know how to use variables, so this should be pretty straightforward to you. And then what we're going to return to the console is that result. Simple as that. Now, you can actually also not use variables, and you could just directly put the operation next to the return statement like that, and that should also work. Let's use our function. Let's actually use our function. So you use your function by calling it by the name, right? You don't have to say def again. You could just call your function again using its name, the name that you provided it. Now let's input 4 and 5 into the function. What happens when we press enter? Oh, we get 16. Why? Because 4 plus 5 is 9, plus 7 is 16. And there you go. You have your first function in Python. Simple as that. You can do a whole bunch of complicated stuff with functions. You can connect this, remember functions, at the end of the day, if you want to like formalize it a bit more programmatically, they're kind of like variables, but instead of storing data, you're storing procedures, right? So think of a function that way. And it's a kind of a variable where you're abstracting a procedure. So if a variable stores data, then a function abstracts a specific procedure, or you're storing a specific procedure. You're reusing code, if that makes sense. So if instead of me having to always do x plus y plus 7 in order to rerun this calculation over and over again for a specific task, I could just call my whatever function to do that for me. So functions are a good way to reuse code, if that makes sense, because they're just abstracting a procedure, right? So if I have a specific procedure that's like, okay, I need to do this, and then I need to do this, and then I need to do this, and if I'm going to be doing that multiple times, then I don't want to have to like repeat that multiple times explicitly in my code. I'm probably going to abstract it. I'm going to call that procedure, I'm going to give it a name, and I'm going to say this is going to be procedure 1. So every time I call this procedure, I don't have to rewrite every single step in that procedure, because now Python knows what I mean by that's by procedure 1. I'm talking about those specific steps that I just defined. Hopefully that made sense. But yeah, I'll give you a more visual example of a function related to the series. First, let's import a library. Let's import random, and let's import time. We've been using the random and time library a little bit lately in our series. This is just for illustrative purposes and to like just get comfortable with our Python. So right now, we are going to code something. So we're going to create a very simple sensor. So here's another way to define a function in Python. This arrow right here is just telling me what this function is going to be, what you're expecting the function to return. This really doesn't have any like functional meaning to it. It's just a good way. It's kind of like comments. You know, we already talked about comments. This is a comment. It's mainly, this right here is just like a notation just to indicate to you or to developers or even debugging tools that this function is supposed to return an integer. So if it's not returning an integer, then something is probably wrong. It's a good way to also indicate to the console if you're using maybe an extension or whatever debugging tools you're using, that is what you're expecting the function to return. For example, here in the little function that we created, we were technically expecting an integer back. We could have also expected a float. That's no problem at all, because we could have inputted 4.3, for example, instead of just 4. But yeah, that's all the arrow is for. It's just a standard practice. Just open up your Jupyter notebook and just code with me. So we're going to be using rand int from last time, and we're going to generate a number from 0 to 100. In fact, this is actually a good moment for me to tell you about methods. So if you remember from last time, a method is really just a function inside a toolkit, a toolbox. So there are multiple toolboxes out there, and these toolboxes come with different functions, right? If a function is part of a toolbox, then you call that function a method. All methods are functions, but not all functions are methods, if that makes sense. So this right here is a function that we created, but it's not a method because it's not part of a toolbox. And you technically don't call it a toolbox in Python. This toolbox that I'm using as an analogy is actually called a class in Python. A class in Python is like a blueprint for a very specific purpose. So, but that's when we get into like object-oriented programming. Right now, this suffices. But right here, what we're doing is we're calling a method or a function from random, right? Which we already imported up here. But that's all you need to know. And what this function does is that it generates a random number from 0 to 100. It could also generate a number from 0 to 50, if I define it that way, right? Right here, these are the parameters that I'm inputting into the function. This is a perfect example, actually. So I'm actually using a function inside of a function. That's very common in Python and in programming in general. And yes, I am copying my example from my phone. I am not ashamed of that because I do not have this code memorized, and that's okay. And you don't need to either. This is just for illustrative purposes. And I'm just showing this live so that you can also code with me. Hopefully you're not just passively sitting there watching. I want you guys to also code with me. Let's see. I need to cut that out. Yeah, I need to cut out every cough that I just made throughout this video because that's embarrassing. Well, and by the way, you can also, from like best practices, you can also define the the data type of the parameter. So here, we define our parameters as x and y, but we can also define that, okay, we need our parameters to be an integer, for example, right? So naturally, we would expect our output to be an integer up here. We could do that, right? Again, it has no functional purpose to it. It's just best practice to let coders know, or people who are reviewing their code, what you're expecting to input into the function and what you're expecting to output from, like what you're expecting your function to output, basically. The arrow is what you would expect the function to output, while the data types in the parameters is what you would expect to input into the function. So this is also known as type hints. Type hints, very common in Python, very common in programming in general. You're giving hints to other developers, you're also giving hints to debugging tools. Standard practices. Here we're defining a parameter instead of calling it x, or instead of calling it y, and instead of it having two parameters, we're just going to have one parameter, and we're going to name it lux. And we're going to expect people to input an integer. We're expecting people to input an integer into our function and return as a string. So this is going to be our decide function. And what are we going to do in our function? What are we expecting to return? What procedure are we returning? What value of a procedure of returning? Well, we're returning on if our lux value is less than our threshold. Otherwise, else, we want to turn it off. Yes, we can actually define a procedure like this. If this sounds a bit uncomfortable, if this looks uncomfortable to you, that's fine. You could define it beginner friendly. If you're not used to this, then you could define it in a more friendlier manner. So, like, for example, if lux is less than threshold, then we will define that as on, else, if lux is less than threshold, on, else, off. That's another way that you could actually, essentially, let's just remove this. If this, then return this. Else, return this. But it's not as, it's a bit more clunky-ish. But if this is more visually appealing to you, then you can do that. But just know that you don't have to do that. You could actually just have this one-liner. It's more practical. So that's just a good note. But right here, we're creating two functions. We've created a read sensor function and a decision function. So these are just very basic functions just for illustrative purposes. But in real, artificial intelligence projects, these functions are going to be calling other APIs. They're going to be maybe retrieving data from a vector database. They're going to be doing a lot of stuff. Now, one more function. Let's call it state. And this function is just going to print. So you can have functions that don't necessarily return anything to the console. They just print. So they just do printing, right? So what's the difference between returning and printing? So when you're returning a value from a function, you can actually take that value and you can store it into some other variable. When you're not using the return and you're using something like print, for example, then you're not really storing it anywhere. You're just printing the value. That's all you're doing. So that's the key difference between return and print. Print light state. So I'm not sure if I already talked about you guys about f strings, but if I haven't, this is probably the perfect time for me to tell you about it. So right here, what I'm doing is called an f string, so formatted string. So a string, we already know that this is a string. It's just a set of letters or a message. It's a type of data. It's a data type where you could just write a specific message. It's not the same as a number. Yes, they're just letters and numbers, right? Really, they're just letters and words, right? That's all a string is. Interesting about a string is that you can actually input a variable inside of the string. So f allows us to do that. It allows us to put a variable inside. So let's call our variable test. Let's say that test is equal to 10, right? Let's just put this number inside. So if I were to run this, see, this is a message 10. So I'm actually able to put a variable, a value from a variable, like a number for example, inside of my message string. Isn't that neat? So that's exactly what we're doing here. We're just storing our state inside of this message. Essentially, let's just finish up the code. I'm going to put my threshold up here, and my functions are all going to be defined in this cell. So let's just continue with the code. Lux is equal to read sensor. So here we're actually going to be using our functions in an actual setting. So here we're just going to define our stuff. Lux is going to be so here we're just calling we're calling our function. We're calling the read sensor function that we created up here, and we're going to be storing it in the variable lux. And what we're going to be doing is we are going to essentially put the function decide inside of the function act. So you can put a function inside a function. Decide, and inside of this function, we're going to be accepting lux. So we're going to be putting lux, that is the read sensor function. Oh man, I inputted lust. Lux, not lust. Inside of the decide function. And then here, we're just going to input a simple delay, right? So we don't get like a whole bunch of messages out there. Output it into the console, if that makes sense. So this is just a simple delay, right? That's what the time. That's why we're importing time. All right, so this is just a loop. This is a while loop. So here is just saying that while true. Basically, what I'm saying here is just that let's just input an infinite loop, right? As long as it's true. As long as this value is true, then continue the loop. Since true is always true and it's always going to be true infinitely, then it's going to be an infinite loop, which is why we're putting this delay right here, because we don't want the entire system to crash, if that makes sense. So what's going to happen here, essentially, is this. So let's just go one by one. So again, you can put a function inside a function, which is pretty cool in my opinion. Honestly, you could just put the function directly in here. There's no problem, but whatever. So what's happening is that inside this, so I'm passing lux, which is the read sensor function, which is this. And what is this doing? This is returning a random number between 0 and 100. So really what I'm actually passing to the decide function is a random number between 0 and 100. Now what is this decide function doing with this random number between 0 and 100? Well, it's taking that number, it's receiving it, and it's being like, okay, is this number less than our threshold? Or is it greater than our threshold? Well, our threshold is 30. So if our random number generated the number 17, for example, well, that's clearly less than 30. So if So it's going to evaluate it so if lux is less than threshold, so if 17 is less than 30, then it's going to be on. If we didn't generate the 17, if we were to generate 55, for example, then it's going to be off, right? So that is how it's going to make the decision. That's why it's called a decide function. That value is going to be stored, right? That's what the return does. The return, it returns it back to our machine in memory, and it's going to store that value. Remember, functions in a way are just variables, but they're variables that store procedures instead of just data, which is the neat thing about functions. So decide is going to store that number, not the number, sorry, but the decision. So it's either going to store on or it's either going to store off. So let's suppose that a random number generated 17. That means it's going to store on. That is what it's going to pass to our act. On is going to be passed to our act function, and it's going to print the state. It's going to be light. It's going to say light on. It's just going to print out a message called light on. And because this is a loop, it's going to repeat that. So let's just run it. Let's run each cell. Remember to run each and every single cell. And here you go. That's it. Lights off, on, off, 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 on, off, and so on and so forth. Because it's constantly looping through our entire while loop. It's just going to loop infinitely. That's why we put this time delay, so it doesn't just crash our entire system. That's really all it is. So this is just a simple example of creating a very simple function. Let's just say a detector, right? If these weren't just random numbers, if they were actual numbers, connected to our environment or a thermostat, for example, it could probably you could set it up so that, it turns on your lights or it turns off your lights, depending on the temperature outside. You could do whatever it is you want with it. So, but this is not really AI. This is still procedural, explicit, deterministic programming, traditional programming. It's still not AI because there's still no statistical learning behind it, and that's the essence of AI, statistical learning. But it's definitely you're definitely building the tools. We're not just jumping into AI. I don't want you guys to just jump into AI. I want you guys to build the tools, not build the tools, sorry. I want you guys to use the tools so that when you actually get into AI, things are just going to be like this for you guys. That's what I want for you guys. I want you guys to be able to just master AI, not be mediocres. Actually be able to use AI, because if you just jump straight to AI, then there's going to be a lot of things that we need to fill before we actually jump into there's going to be a lot of friction. There's going to be a lot of missing gaps in the knowledge. And I don't want that stuff for you guys. I want you guys to actually learn everything from ground zero all the way to expert. That's also my personal goal, which is why I created this channel. I want to document my journey, and I want to build a community of people who are also serious about this stuff. If that's something that interests you, follow, give it a like, subscribe, share the video. We're growing this channel. As long as I don't die, then that's the goal of this channel. The goal of this channel is to create a community of people who are serious about artificial intelligence and applying artificial intelligence and just making the world a better place. I want to use AI to transform the way we think, the way we learn. Because personally, I'm a polymath, so I like to learn a bunch of stuff. I want to learn math, science, physics. I want to learn everything. And I think that AI is definitely the key for us polymaths. And I want to explore those options with AI. Your purpose for using AI might be different, and that's okay. Everyone's different. But whoever you are and whatever you want to do with AI, these are the tools, these are the basic tools that you need to master. You don't need to know everything about Python, but at least learn the basics. You don't need a super advanced PhD degree in order to get into AI. This is a very fun industry. It's also a very complicated industry, and it's also a very competitive industry. So it's very essential that you learn the fundamentals, and this is what this series is about. So if you enjoyed, again, like, subscribe, follow, share, all that YouTube algorithm stuff. I'll see you next time.